One of the topics that comes up in this section is writing derivatives in differential form. Um, this is a topic that's probably a lot less difficult than its name makes it sound. Let me just show you what's going on here. We normally write that the derivative dy over dx is just another way of writing f prime of x. This is the case if, let's say, y equals f of x. If y is f of x, we can write the derivative as either dy over dx or f prime of x. So if I simply multiply both sides of this equation by dx, I just get the equation dy equals f prime of x dx. We covered earlier the picture showing what dy and dx refer to. This does make some sense when you think about it, because what it means is that if I have something like this, what I can say is that if I move dx in this direction, then if I follow the tangent line, I end up moving dy in that direction. So in other words, the ratio of how much I move in the y direction over how much I move in the x direction, which you see there, is just equal to the derivative of f at a, which gives us the slope of the tangent line. So that's kind of the picture showing the theory of it. But the important thing to remember is just that I can take this derivative, dy over dx equals f prime, and just rewrite it in this form. What does an example problem like this look like? Let's suppose that we want to find the derivative of a function like e to the x sine x. Sorry, the differential of e to the x sine x. The way we would do that is we'd simply say, what is the derivative of e to the x sine x? And using the product rule, we get e to the x cosine x plus e to the x sine x. Hopefully this looks familiar to you. So what we know is that if that's the derivative, I can simply take both sides of this equation and multiply by dx. That makes this dx here go away, and that gives us the differential of e to the x sine x is equal to e to the x cosine x plus e to the x sine x times dx. And that's what that means. So if it seems like there's really not much to this, there's not. We are going to make some use of this expression, but in terms of how to find the derivative, really all you do is you just find the ordinary derivative, and just the way that you ordinarily would, take the whole expression you get and multiply it by dx, and that gives you the answer. So let's just do one more of these. Let's find. This can be a review of some other topics in derivatives. So let's suppose we want to find the differential of arcsine of 5x. What we would do is simply find the derivative of arcsine of 5x. We know that the derivative of arcsine of u is 1 over the square root of 1 minus u. So that's going to be, sorry, the square root of 1 minus u times the derivative of u. So this is going to be 1 minus 5x squared, and then by the chain rule we have to multiply by the derivative of 5x, which is 5. So we get that. We simply multiply by dx and we're done. Except we can at least clean up the expression a little bit. This is going to be 5 dx over the square root of 1 minus 25x squared. So either this or this would be a perfectly valid answer to that question.